All right, we're going to go ahead and continue solving trigonometric equations. All righty. And if you hear a little bit of ruffle in the background or something like that, I'm doing these videos all up in the garage right now. I'm just going to let you know. And it's late at night and it's raining. It's like hailing outside. Okay, you know what I'm talking about? Sometimes it get a little loud, so can't be doing the videos at night when the L children are sleeping. So kind of have to get up on my desk here in the garage. So it's kind of hitting the garage there. So if you're going to hear a little something, that's all it is. So I don't know. I don't think it's your speakers on your computer there. Anyways, back to our problem here. We're going to go ahead and solve 2 cosine of x plus 1 equals 0. All right, so just like we did in the last example, let's go ahead and solve for cosine of x. Okay, so we're going to go ahead and subtract 1, and we're going to divide by 2, which means we'll have cosine of x equals negative 1/2. All right, so just think back onto the inner circle. What x value has negative 1/2? Well, there's 2 of them. Let's see, one of them is 2 pi over 3. Oops, 2 pi over 3. And the other one, where it's going to give you negative 1/2, is going to be 4 pi. Let's see, 1, 2, 3, 4. Yeah, 4 pi over 3. Okay? But let's remember that at these increments right here, right? So if I'm at 2 pi over 3, right? So it's going to be about like right here. Okay, so that's 2 pi over 3. See, that's 2 pi over 3, right? But then if I do one full rotation, that's another 2 pi over 3. And then another 2 pi over 3. Oh man, there's like thunder outside. Crazy. All right. So that's why I need to put plus 2 pi n, because I'm going to keep adding 2 pi over 3. I'm sorry, I'm going to keep adding 2 pi and land back at the same spot. And I say n is within the integers. Because as we know, the cosine graph continues infinitely, which is why it's going to equal negative 1/2 infinite times. So we have to represent our answers that represent all the answers there. 4 pi over 3, and that is add another 2 pi n, where n is within the integers. And so if you only put 2 pi over 3 and 4 pi over 3, you're only giving 2 answers out of infinite answers. And only having 2 out of infinite is really nothing, right? So that's why you want to represent your answers in the form of infinity or all the answers, which is why you have to do this whole mumbo jumbo 2 pi n, where n is in the integers.